Welcome back to Mega Engineering Explained, where we break down the structures that pushed human engineering to its absolute limit. Today, the tallest building on Earth and the invisible enemy it was secretly designed to outsmart. Rising out of the desert in Dubai is a tower so tall it seems to belong to a different scale of reality. It stretches more than 800 meters into the sky. From the top, you can watch the sunset twice, once from the ground and again as you ride the elevator up. This is the Burj Khalifa. Was the favorite in the weight to wastes never who were even. Radium, it's 828 meters tall. That is though amped. It reads another net of data 100 areas and touching humans is tall, reaching higher than any structure humans have ever completed. When it opened in 2010, it didn't just break the record for the world's tallest building. It shattered it, leaving the previous Champagne 101 far below. Simply moving people up and down a tower like this is its own engineering feat. Its elevators are among the fastest in the world, racing upward at building decks and higher. Edge grades can look crash in the town, everything graphics and something else building elevator to live on a stale build it's not worlds and a battle it up at that never going to Gillsbury. It's not fair really about it really. Who the engineers were was understood headers son upgrade the time of into visually relates for Naquime. The true enemy of a super tall building was something you cannot see set type Varbo sort of gets strong thing. Something worth quitting this higher to use hair. Move on. Here is the problem. Wind flows past tall and tower doesn't just push on it. It peels off the sides in swirling gusts called vortexes. And if those vortexes start shedding in a steady rhythm, they can shove the building back and forth, again and again, in time with its natural sway. Left unchecked, that rhythmic push can make a skyscraper oscillate violently. If that sounds strange, think of pushing a child on a swing. One random shove does almost nothing. But if you time your pushes to the swing's natural rhythm, it climbs higher and higher with hardly any effort. The wind can play that exact game with a skyscraper, if it is ever allowed to find the beat. And the taller and thinner the tower, the more dangerous that game becomes. For a tower as tall and slender as the Burj Khalifa, that shaking wouldn't just make people at the top feel seasick, it could threaten the structure itself. So the engineers at the firm SOM faced a defining question. How do you stop the wind from finding a rhythm to push against? Their answer was brilliant, and a little bit sneaky. They didn't try to simply overpower the wind with brute strength. Instead, they designed the tower to confuse it. The trick is hidden in the tower's shape. Seen from above, the Burj Khalifa is not a square or a circle. It is a Y, 3 wings reaching out from a strong central core. This is called a buttressed core. The central spine gives the tower its stiffness against twisting, while the 3 wings brace against each other and push back against the wind. That Y-shaped footprint was chosen specifically to break up the wind and make the tower easier to build at the same time. But the real magic is what happens as the tower climbs. The Burj Khalifa does not rise as a single straight shaft. As it goes up, it steps inward through a series of setbacks, spiraling around the building as it gets thinner and thinner toward the sky. And that spiraling shape is the key to defeating the wind. Because the tower is a slightly different shape at every height, the wind hits a different profile at every level. The swirling vortexes can never line up. They can never organize into one single powerful rhythm. Instead of a coordinated push, the wind is scattered into confusion. The tower quite literally refuses to give the wind anything steady to grab onto. To get this exactly right, the engineers didn't just guess. They built models of the tower and ran more than 40 separate wind tunnel tests, blasting the shape with air to study every gust and swirl. They kept refining the spiraling setbacks until the wind simply could not shake the building. They outthought the sky. And here is the counterintuitive part. The goal was never to make the tower perfectly rigid. A building this tall is meant to move, to flex gently with the wind rather than stubbornly resist it. The real triumph is not that the Burj Khalifa stands perfectly still. It is that it moves exactly as much as it should, and never more. But designing a tower this tall is only half the story. You still have to build it, in the middle of a desert, in punishing heat. And that created a problem almost as brutal as the wind. How do you get wet concrete hundreds of meters up into the air before it hardens? The answer was to pump it, higher than concrete had ever been pumped before. During construction, the crews forced concrete up through pipes to a record height of around 600 meters from the ground. To survive the journey and the heat, they used a special high-strength concrete, often poured at night when the desert was cooler, sometimes chilled with ice. The outside of the tower is wrapped in tens of thousands of glass panels, a shimmering skin built to bounce back the brutal desert sun and keep the heat outside. Simply cleaning that surface is a permanent job of its own, a small team of workers slowly making their way around the tower, hanging high above the city below. Beneath all of it, hidden underground, is the foundation that holds this giant steady. The tower sits on a massive slab of reinforced concrete, several meters thick. And that slab is supported by a forest of concrete piles driven deep into the ground, spreading the tremendous weight into the earth below. And right at the very top sits the tower's crowning needle, its spire. Rather than lifting it up the outside, the engineers assembled the spire inside the building and then jacked it upward into its final position from within, like a telescope extending toward the sky. That final piece pushed the Burj Khalifa to its full, record-breaking height. There is one more twist to the story, and it is written into the tower's very name. During construction, it wasn't called the Burj Khalifa at all. It was known as the Burj Dubai, but as it was being finished, a global financial crisis struck and Dubai needed help. Its neighbor, Abu Dhabi, stepped in. In gratitude, the tower was renamed in honor of the ruler of Abu Dhabi, Sheikh Khalifa. So the name on the tallest building in the world is a permanent monument, not just to engineering, but to the moment one city reached out to rescue another. On a clear day, you can see that monument from nearly 100 kilometers away. Think about what this tower really represents. It is not just the tallest thing we have ever built, it is proof that the biggest challenges in engineering are often invisible, visible. The Burj Khalifa didn't conquer the wind by being stronger than it. It won by being smarter, by twisting its own body into a shape the wind could never quite understand. Some structures overpower nature, this one outwitted it, turning a deadly force of moving air into something harmless, just by changing its shape as it climbed. That is the difference between building tall and building brilliant. But not every megastructure reaches for the sky. Some of the most incredible engineering on Earth goes in the opposite direction, plunging deep beneath the sea. Somewhere out there, engineers dug a tunnel so far under the ocean that trains now race through the seabed itself. That is the next story. Of bird on Mexican launches. If this blew your mind, hit that like button for more megastructures and tell me in the comments which one I should cover next. Thanks for watching, and I'll see you in the next one.